X.
Hey everyone, welcome back to another COMSOL tutorial with Cabin the X. Today we are going to conduct a simulation in relation to flow through a pipe elbow. The simulation focuses on the K omega turbulence model. You must consider that in an engineering context, pipes and fittings are not normally the subject for turbulence modeling. There is a vast amount of tabulated data and correlations that can be used in simplified approaches such as those used in the pipe flow module. But now, more and more detailed studies are required. For example, to generate additional correlation data or to understand phenomena caused by a secondary flow pattern. The flow conditions are typical to those that can be found in the piping system of a nuclear power plant. In regards to our model definition, it's a 90-degree elbow. Our pipe is a 90-degree elbow. The diameter of the pipe is 35.5 millimeters. The coil radius, which is coming around here, that's 50 millimeters. The inlet, the straight inlet, that would be 70 millimeters. That's the straight coming off the bend, and the outlet would be approximately 350 millimeters, and that's going out from the opposite side of the bend. In terms of materials and properties, our temperature is 90 degrees. That would give us a density of approximately 965.35 kilograms per cubic meter. For pressure, that would be absolute. That's going outwards. That would be 20 bars. We need to also consider that the water is approximated as an incompressible fluid, and the flow at the inlet is a fully developed turbulent flow with an average inlet velocity of 5 meters per second. Here are our global definitions. I'll provide these in a CSV file as well as a text file, which we can insert directly into COMSOL. Let's begin. So let's navigate to our model wizard. Let's select three-dimensional space. I recently used a turbulent flow, but I'm going to show you how to navigate to that. So let's go to fluid flow, single phase flow. Let's navigate down to turbulent flow and expand that. And let's navigate now to turbulent flow K omega SPF. Then click on add. Now click on study. Stationary. Done. Before we continue, let's save and give our project a name. So let's save, and I'm just going to call this that. You can navigate wherever you want to save it and give it whatever name you want to give it. So I'm going to call it that. Now we are going to set up our global definition parameters. Before we do that, I'm going to show you the files that can be inserted into COMSOL rather than typing it all out. So here I have a CSV file and a text file. Any one of these can be inserted. I've already set them up the way they should be. So let's go and insert those to COMSOL. So let's navigate back to our model builder right here, and under global definition, so you can just expand it out here. Let's click on the parameters, and what we are going to do, we are going to insert our parameters by just clicking load from file right here, and I'm going to say load, and this will take us to the folder. And if you're not seeing a CSV file, you can just expand here, select CSV, and you will see it. Alright, so anyone, you can use anyone, or you can just click all files and you will see everything that's in your folder. And now I'm just going to select the text file and then open. And here is all of our parameters that we need for our simulation. Now let's construct our geometry. So let's go to the geometry toolbar. Let's click on work plane. In our work plane settings, let's go to plane type, and we're going to select the YZ plane. For the X coordinates, let's type in LIN, that is from our global definition parameters, and let's come here, expand this, click on work plane 1. We are in the sketch, so now let's click on circle. With circle activated, let's click here, and let's just expand out. Anywhere out, we will make the adjustments in here. So for the radius, let's use our diameter that we inserted from a global definition parameter, and we're going to divide that by 2. Now let's expand rectangle. Let's select square, and let's just draw a square here. We will make all our adjustments in the settings. So in terms of the size, side length, let's enter D, and in terms of position, let's enter minus D divided by 2, and we'll enter that in the XW text field. So minus D over 2, and in terms of our Y, let's use minus D. Let's go over to our work plane toolbar. Let's expand booleans and partitions. Let's select difference. Now you realize that our square has been adjusted. So now let's go to zoom to extents. With this we can see it more clearer rather than that small little figure. Where we have objects to add, we can now go over to our selection list, and we can select C1, and let's click add. Go back to our model builder. Now if you wonder how I get this, I'm going to close it, I'm going to exit out, and then I'm going to go home. I'm going to go to Windows, and here it is, selection list. So once you click that, you always have it next to your model builder. Okay, now let's go down to objects to subtract. Let's activate that right there. Let's go back to our selection list, and we can click on square, add back to our model builder. The geometry isn't complex. We could have select the geometry from here as well, or here, but I'm in the habit of using the selection list. With this, when we have a geometry that is more complex, it's easier to come here and select what you want. Now we can just select or click on build all right here and zoom to extents, and here is our semi-circle. Let's go back to the model builder and let's click on geometry here. Now let's go to our geometry toolbar. Let's navigate to revolve. And let's look for the revolution angles inside of our settings. So here it is. Let's click angles, and for the end angle, let's enter 90 degrees, and we already have our selection here. This is the one that we need. So if we go to selection list, that's the only surface that we need, and it was selected for us automatically. If it wasn't selected automatically for you, you can go to the selection list, select it, and then click add. Okay, now let's go back to the general area and let's look for input object handling, and let's select P. Let's now look for the revolution axis. So let's scroll down by using the scroll bar on our right, and let's look for the point on the revolution axis, and for the XW, let's enter our RC that we took from the global parameters, and for the YW, let's enter LIN, which is also from the global parameters. And let's build selected. Let's zoom to extents, and here is our coil radius. We are now going to create our inlet and outlet straits for our pipe. Let's go over to our geometry toolbar. Let's select extrude, and we are going to enter LIN here, which is our length in from our global parameters, global definition parameters. Let's select the reverse direction. Let's zoom to extents, and let's go over to our model builder. We have revolve, we have extrude, okay, but we want to go to geometry, the top of geometry, where we have our work plane one. We're gonna right click on that, and we're gonna copy, and let's right click on geometry one, and we're gonna paste that. Alright, so paste work plane. Let's now select work plane 2. expand that. That looks okay here, but we need to go to our settings for work plane 2, and on the plane definition for the plane list right here, we need to select that would be the XZ plane. Okay, and for the Y coordinate, we need to type in our RC from our global definition parameters. In the model builder window, we already expand our work plane 2, so let's go down to the plane geometry. So let's expand that. Let's click on the circle 1, and in the settings for circle 1 on the work plane 2, that is, we now need to go down to the position, and for the XW we need to enter our length in plus our coil radius, which is RC. Okay, and now for the square, so let's go back to our model builder here. Square, let's enter minus diameter divided by 2, and we need to add the length in and the coil radius. So we'll go to position XW, so we're going to add to that plus length in plus our coil radius. Okay, let's now go back to our model builder window. Let's go to geometry, let's right click, let's select extrude, and let's select the reverse direction box, zoom to extend, and for the distance we need to enter our length outwards. And now let's build all. You can select build all from here, or we can select build all from the geometry toolbar. And now zoom to extends. Here we have our geometry nicely constructed, so let's go ahead and collapse our geometry so this can be more clear and neat and easy to navigate. We now need to build our mesh control faces. So let's stay in our geometry toolbar where we have virtual operations. Let's expand that and let's select mesh control faces, and let's click on paste where we have input faces to include. You can do it many ways. I already showed you the selection aspect, but we can also select paste and we can enter 5 and we can enter 11 and click OK. So here they are. If we go over here, you gotta select them from here and here as well. So that's just another way of doing it once you know what they are. Now let's select or click on build all, and that is now being completed. Now we need to set up our material. So let's collapse our geometry once more. Let's navigate back to our model builder. We need to right click on materials, select blank material, and for the value, let's enter RHOF. That's also in our global definition parameters, and mu f for the viscosity value. And for the label, let's just call it water. Okay, we'll now proceed to setting our study. Okay, so under our model builder, let's collapse material. We need to right click on turbulent flow, and we're going to select inlet. For our inlet, for the settings, let's go to our boundary conditions, and let's change that from velocity or whatever you have selected to fully developed flow. And for the fully developed flow or average velocity, we're just gonna enter the name of our average velocity within our global definition parameters. So that's UAV3, and also we need to select our boundary, and we want boundary 1. You can decide which way you want to select that. I'm going to do it from my selection list. Okay, and that's our inlet right here. You could have done it from here, here, or here. Alright, now we need to set up our outlet. Let's just use the left mouse button, and we're going to rotate just so we can see both sides a little bit. You can see the inlet and you can see the outlet. Okay, now we can right click again on turbulent flow, or we can go to our physics toolbar. It doesn't really matter which one, but I'm just going to right click here, and then I'm going to select outlet. And for our outlet, for the boundary selection, I'm going to go here, I'm going to select 5. You can see it highlighted here. While I select it, I'm going to add. I'm going to go back to the model builder, and same process for the boundary condition. We're going to select fully developed flow. Now we need to create a symmetry, so let's right click here, symmetry, and we need to go to our selection list, tree, add. So that's for boundary selection. It's time to create our mesh. Okay, so let's go back here, zoom to extend if it's not, and let's go to our model builder. We're going to click on mesh 1, and in the settings for mesh 1, we are going to locate the physics control mesh section, which will be here. We need to change our size from normal to extra fine, and let's right click on mesh right here, and we're going to choose edit physics. Edit physics included or induce sequence, that is. With size selected, we need to expand element size parameters, and for the maximum element size, that would be parameter divided by 20, and for the minimum element size, we're going to leave it as is. Okay, let's go back to our model builder, and we are going to disable size 1 by right clicking on it and select disable. The same goes for these two, so I can select corner refinement and the free tetrahedral. So I can do both of them together by using control, right click, and disable. Okay, let's go back to our model builder. Let's click on boundary layers, and in the geometric entity selection, which is here, we only need the boundary 1, so we can select 3 and 2, so by using the control button, and we can delete them by clicking here. And now for the boundary layers, we need to expand it from the model builder. So we have the boundary layers properties. Let's click on that, and we only need edges 1 and 4, so let's just clear here, clear selection there, and let's go to our selection list. Let's click 1, 4, add, go back to our model builder. In the layer section, it's collapsed for you to expand it. The number of layers, enter 6, and for the thickness adjustment, kindly enter 2. Let's navigate to the mesh toolbar, and we're going to create a sweep. Let's expand controlled entities right here, and let's clear the smooth across, remove control entities. So let's clear that box, and let's right click on sweep 1, and let's create 3 distributions. That's 1, that's 2, and that's 3. Let's go in order, so let's go back to distribution 1. For distribution 1, we don't need domain 3 nor domain 2, so let's delete those. And for the number of elements, let's enter 40. Okay, now let's select distribution 2, and for that one we don't need domain 3 and we don't need domain 1, so let's delete those. And for the number of elements, let's enter 50. And for distribution 3, we need to delete 1 and 2, and we only need domain 3. For the distribution type, let's change that to predefined, and for the number of elements, let's enter 70, and for the element ratio, let's enter 10. Let's go back to the mesh toolbar where you have more generators. Let's expand that, and let's select free triangular, and for free triangular let's select boundary 1. Let's add a boundary 1, and let's go back to the model builder and let's build all. So we can either build all here or here, and that will take a minute or so, maybe less, depending on the speed of your computer. If you have this error, don't panic. Let's go and fix it. So we can just click OK, it's not a problem. And all we need to do is left click on this, hold it, drag and drop it below free tetrahedral 1. Okay, and let's build all again. And that fixed the problem. Before we run our computation, let's go back to distribution tree, and where we have growth rate, let's change that to exponential. Okay, let's just double check that our number of elements is 70, our element ratio 10, and growth rate, change that from linear to exponential. With that done, let's go ahead and build all again. Let's double check our boundary layers. Here under geometric entity level, we have domain selected. Let's change that to boundary, and let's go to our selection list, 1, add, and go back to our model builder. Now let's go down to our boundary layer properties, and now we have edge for our geometric entity level. So let's go to our selection list, and we want 1, control on the keyboard, 4, add. So we have these two edges, and that should be our correction. Let's build all again and go back to our model builder. Let's double check our sweep, our distribution. Okay, it looks okay. Let's go ahead and run our computation, but first let's save. So I'll leave it to save and run our computation. Now that our computation is completed, let's collapse all the entities that we don't need at this moment, and let's just focus on our results. So let's select results here. We can check this box where it says only plot when requested. This will deactivate the automatic update of plots because we are working with large 3D models, or when you're working with large 3D models. So let's go over to wall resolution. Let's click plot. Let's rotate this a little bit and just examine it. Okay, so as you can see, the wall lift off is well below 100 viscous units. This occurs everywhere, and the flow can therefore be regarded as a well-resolved at the walls. So let's go back to our default view. Let's take off this grid for now. Zoom to extents, and let's go ahead and create a surface. So let's go to pressure in our results, and let's right click on surface, disable. Let's right click on pressure, and let's create a streamline. Do you see that here? Yes, let's create a streamline there, and let's go to our data set, and let's choose study 1 solution 1. Let's go to our streamline positioning here, and for the position in, let's change this from starting point control to unselected boundaries. Let's come to our pace selection, and let's just enter 1. As you know, you can go to your selection list. I'll just click here. Those are the methods, and let's go to our streamline settings, go down to coloring and style. In our coloring and style, for our line style right here, let's change this to tube. Let's go right click on streamline, and let's choose color expression, and while we are in the pressure toolbar, let's just hit plot. Let's just rotate this so that we can observe the inner portion of the bend. Okay, that looks okay. Let's rename it. So let's right click here, rename, all the velocity streamlines. Let's go back to our default view, zoom to extents. Now let's create a plane. So in the results toolbar, let's create a cut plane. For a cut plane, what plane type? Let's use a general plane type. For the plane entry method, let's choose point and normal vector. For the point X, we'll use length in. For the normal vector, for the X, let's enter 1. For the Z, let's enter 0. Okay, and let's duplicate this. And for cut plane 2, in regards to point, let's just add RC to this. And for the Y in the normal vector, we enter 1. Now let's go to our results toolbar. but we are still in our results toolbar actually. So let's go to more data sets and let's choose evaluation. Let's select under evaluation, let's select average, and for our data set let's choose cut plane 1 and let's create another average, and let's choose cut plane 2. Let's now go back to more data sets and let's look for join right here, and for data 1 let's select average 1 here, and for data 2 let's select average 2. Now let's go to our results toolbar and let's create a evaluation group. So let's expand this, and we should have evaluation group here. Select that. So let's go ahead and create our pressure drop. So let's right click on evaluation group, and we're going to create a global evaluation. Let's call it pressure drop, and for the dataset section make sure we join 1, and here let's enter E. We should enter 1 here, and the description should be pressure drop, and we need to evaluate this. So let's click on evaluate. The pressure drop is now completed by subtracting the mean pressure evaluated at the cut plane. It was done just before the bend from the mean pressure evaluated at the cut plane in the middle of the bend. So let's just rotate this just a little bit right here, and let's pan up and zoom in a little bit. Okay, let's now create our calculated friction factor. So let's right click on evaluation group, let's create a global evaluation. Let's call this one calculated friction factor. Now let's enter the friction factor equation. I'll also provide this in a text file, and for the unit 1 and for the description let's call the friction factor. Okay, for the data set let's choose join 1. Now let's create the correlation for the friction factor. So let's right click on evaluation group, let's create another global evaluation, and let's call this one correlation for the friction factor. So let's type factor at the end here, For the data set, let's choose 31 solution 1. For the expression, I'll provide a text file. So you will have the calculated friction factor here, and this is a correlation for the friction factor. So let's copy that, and let's enter that here for our expression. The unit would be 1, and the description would be correlation for the friction factor. So let's evaluate. Here in our evaluation group, you can see our pressure drop, you can see our friction factor, and you can see our correlation for the friction factor. Let's now create a 2D plot group. So let's go home and let's go to add plot group, 2D plot group. For our data sets, let's change that to cut plane 2. Let's navigate down to our color legend and let's select show maximum and minimum values. Now let's go over to our model builder. Let's right click on 2D plot group 4. Let's select surface, and for our surface, let's look at the expression, and in our expression, let's just type P, and let's hit plot, and let's rename our plot group. Let's rename that to cut plane pressure distribution. This gives us a surface plot of the pressure in the plane at 45 degrees. Before we conclude, here is a useful article on secondary flows. I'll provide the link in the text file as well. This concludes this COMSOL simulation. Please like, subscribe, and share. Thank you. Goodbye for now.